Welcome to the next video of this transitioning to the AI engineering series. Last video we talked about why Python became the standard language for AI. In this video we will talk about how Python handles those types. We have been writing code for years. We always knew what the type of our variable was. The compiler made sure of it. In Python that's gone. Let's see what that looks like in code. Here we have one variable x. First we assigned an integer to it. Then in the next line we assigned a string to it. Then we assigned list and then to a lambda function. So finally we checked its type. It shows it's a function. So same variable assigned 4 different types of values to it and we get no compiler error or runtime error. Now, if you are coming from Java or C++ background, this looks wrong. One variable, we cannot assign different types of values to it. But in Python, this is completely valid. Now, let's understand what is actually happening. In Python, X is not like a box that contains value and the type information both, like it used to be in Java or C++. In Python, X is like a label, and we can stick this label to any object we want. No restriction. So what it does is it creates a brand new object in a different memory location and moves the label X to point to that location. This is the key idea. In Python, a variable is just a label. The variable has no type. The label has no type. The object it points to, it does. This is called dynamic typing. The type of the object is determined at the runtime, not at the compile time. If that object supports that action we perform on it, things will work. Otherwise, it will error out all at the runtime. Now let's talk about duck typing, what it is. There is an old saying, if it walks like a duck and quacks like a duck, it's a duck. Python uses this as a programming principle. It does not check what an object is, it only checks what it can do. So if we write a function that slices something, Python does not verify the type. It just tries to slice it. If the object supports slicing, it works. If it does not, it may error out. So if you can see, list, string, tuple, all support slicing, all work. Integer does not support and it gives type error. So the thing is, Python only finds out when it tries. This is exactly why PyTorch and NumPy functions, they don't care what specific type we pass it. As long as the object supports what the function needs, it should work. Next, let's talk about the type hints. Now, here's what trips up almost every engineer coming from a typed language. We need to understand that type hints are for our IDE. Python ignores them at runtime. They are for documentation and not for enforcement. If we need actual runtime validation, then we can use Pydantic, and which is what Fast API and most AI frameworks use under the hood. We will cover those later one by one. So what we learned in this video is that dynamic typing is not a lack of discipline. It's a design choice, and it's exactly why the entire ecosystem, AI ecosystem, is built on Python. So let's embrace it. Use type method when we want to debug the code. Use type hints when we want the clarity and documentation. This is it for this video. Thanks for watching. Please subscribe if you liked it. See you in the next one.